All right, guys, now it's time to subtract our polynomials. And this is when you're going to see why we have parentheses around them. Okay? If you remember, I'm going to start out once again with kind of simplifying some. If you remember, if you see a negative inside or to the outside, that means there's a -1 there. Okay? And if you remember, with that -1, that means you distribute it to all 3 pieces. So that means you're going to do a -1 times a positive 2x to the 3rd power. So it's going to become -2x to the 3rd power. This one, a -1 times a -3, means it becomes a positive because a negative times a negative makes positive. And then -1 times a positive 7 makes that a -7. You can also remember this, everything comes out its opposite. So since this was positive, it became negative. This was negative, it became positive. This was positive, became negative. Okay, let's try one more of those. Okay, so here is another one. Okay, once again, think about it as having the -1. Distribute that -1 into each piece. And if you remember, it comes out opposite. So since this is a -x², it becomes +x². This then becomes, since it's positive, it's a -x. And since this is negative, this becomes a +3. Okay, this is simplified. Nothing more we can do. We don't have an equal sign, nor do we know what x is equal to. Now this is going to become important with subtracting polynomials. Okay, so once again, here is one. Okay, as you see, we still have parentheses on both pieces, and then the subtraction sign between. Now, with it being polynomials, that means we're subtracting a -1. But that also means since this is going to be a -1, we're going to distribute it in. And when we do that, then this becomes addition. So now I'm going to rewrite it so it becomes 2x² plus 6. Then I'm going to distribute. It becomes positive. It's going to become plus a -4x. Okay, so now we can combine our like terms, or in this case, there's nothing more that can be done here. Okay, so you can rewrite it, and if you rewrite it in standard form, it becomes 2x minus 4x plus 6. Okay, so now you have it in standard form from the highest degree to the least degree, and your constant always being last. Okay, so let's take a look at another one. So in this case, we have 4a minus 2a minus, inside a, 3a to the 4th power minus 3a plus 1. Okay, so once again, we're going to distribute here, aren't we? Okay, so then this is going to become, this is going to stay the same. It's going to become addition. Distribute that, so since this is a positive, it'll become a -3a to the 4th. Distribute the -1 to this, so it's going to come out its opposite to be a +3a. Distribute this to my 1 to the back, becomes out to be a -1. Okay, and just like adding, now I can add them. So combine your like terms. I'm going to go ahead and bring these two over here to the trinomial. So 4a to the 4th power goes here. And it's adding. You could think of it as having a 1. Then plus 2a. And I have nothing here, so I'm just going to put a plus 0, just kind of hold that spot. So then adding your columns together like we did the first lesson from yesterday. So -1 plus 0 is still a -1. 3 plus 2 makes it a positive 5a. And then a -3 plus 1 makes it a -2a to the 4th power. Okay, once again, there's nothing more we can do. We don't know what a equals to. We don't have an equal sign. So we are done there. Okay, let's take a look at one more. Okay, so once again, I'm going to go ahead and rewrite this one. Oops, I almost made that positive. It's a negative. Minus 2x plus 8. keeping its parentheses. This is going to become a plus because I'm going to distribute. So if you want, you can make it a negative 1. So since this is a positive x squared, it becomes a negative x squared. Distribute the negative 1 times the negative 4 becomes a positive 4x. Okay, so once again, combine our like terms. I'm going to move them over the binomial to the trinomial. So I have a negative x squared. It's going to go under here. You could think of it as a negative 1x squared. I don't have an x with a 1 degree, so I'm just going to put a plus 0x to hold the spot. Then I have a plus 4, which will go with the other constant. Okay, once again, add your like columns. This is 12. It's positive. This will be still the negative 2x. And then 3 minus a 1 is a 2x squared. Once again, this is your final answer. There is nothing more we can do. All right, one more. All right, so let's take a look. Once again, it's going to be 11x to the third minus 2x. Nothing changes. Keeping its parentheses. Distribute the negative 1. So add the addition. So it becomes negative x to the third power. Distribute the negative 1 to the negative 5, and it becomes plus 5. Okay, I'm going to move these two over here. So I'm going to add 11 to here. So 11x cubed, or to the third power. I don't have a minus 2. I'm going to write it out here to the side. And I'm just going to kind of put over here that we have a plus 0x. Okay, and here we don't have a constant, so I'm going to put a 0. Okay, so then, think about this, it's the negative 1. So a negative 1 plus this makes it 10x to the third power. My constant stays a 5. And then here it's 0 minus the 2x, so it's 2x. Okay, now if I rewrite this and make sure it's in standard form, highest degree first, so 10 to the third. So 10x to the third power minus 2x, and then your constant is last. Okay, and so that is your final, most correct answer. Okay, all right.